In this question, we're asked to find the actual value for the sum given this for the series. So it wants to know what the true value is when I add up all the terms starting with n equals 2 and adding all the way to infinity. Now this must be a geometric series because that's the only kind of series that we've learned how to find the true value for the series. Otherwise we've just for the integral, when we use the integral test we can actually bound the value for the series sum between a lower and an upper bound, but all our other tests are just does it converge or diverge. So this must be a geometric series, and I must be able to use this geometric series formula to figure out what the sum is. So I'm going to try to re-express it as, deal with the plus 1 in the exponent, work with the exponent enough until I see it as some number times the sum of some ratio to the power n. So the first thing I'll do is break up the addition in the exponent for 3, so n equals 2 to infinity, 4 over 3 to the 2n times 3 to the 1. Then I can pull the 4 from the numerator and the 3 from the denominator out. I'm adding from n equals 2 to infinity of 1 over 3 to the 2n. But I really want to think of that as 1 over 3 to the 2 to the n. So then that's 4/3 times the sum from n equals 2 to infinity of 1 over 3 squared is 9, so 1/9 to the n. And now it looks very much like a geometric series, but I still have the issue that this index, the lower index, is a 2, and my formula that I know for the sum of a geometric series is when it starts at 0. So I need to re-index. So I have my 4/3, sum from n equals 0 to infinity, 1/9. So I lowered the bound by 2, so I need to increase the n by 2 to compensate to the n plus 2. So that originally in the line above the last line, when I plug in n equals 2, I get 2 for my exponent. And in the last line, when I plug in my bottom bound, which is 0, I also get 2 for my exponent. So all I've done is re-express the sum, but it's still the same sum. So now I'm going to do that thing with the exponent again. I get 4/3 times the sum from n equals 0 to infinity of 1/9 to the n times 1/9 squared. So then I can pull the 1/9 squared out as well. So I have 4/3 times 1/9 squared times the sum from n equals 0 to infinity of 1/9 to the n. Now that series, the sum from n equals 0 from 1/9 to the n, is a geometric series in standard form, so I can use the formula to sum it. So I still have 4/3 times 1/9 squared, and for the sum for this geometric series I get 1 over 1 minus 1/9. That ends up being 4/3 times 1/9 squared times 9/8. And then if I simplify, I end up with 1/54. So the sum for this series is 1/54. And we used our rule for the sum for a geometric series, but we had to make sure we got it in standard form first.